All right, so here are the multiple choice questions you guys requested. Starting off, let me move this out of the way for you. All right, so first question, let f of x be a function that's continuous on the closed interval. So just the fact that it says that, I always do things like that. I know those two are true, such that f prime does not exist. So if f prime at 0 does not exist, things that I'm thinking about. Then at 0, the derivative is undefined, but since it was continuous, we don't cross it out. I am thinking about corners. I'm thinking about a cusp. I'm thinking about a vertical tangent. Those are places where the function's continuous, but the first derivative is undefined. Then it says f prime of 2 is 0. So at 2, f prime is 0. And f double prime is less than 0, means we're concave down. For all except where x is equal to 0. So the whole entire function is always concave down. I'm going to look for a corner, a cusp, or a vertical tangent at 0. So let's start with that. That's actually pretty easy to identify. So we know this has a corner, that has a corner, that has a discontinuity. This has no issue at x equal to 0, and this has a corner. The second thing I can look for is a horizontal tangent at x equal to 2. So at x equal to 2, horizontal tangent, we're good. Horizontal tangent, we're good. And horizontal tangent, we're good. So that really didn't help us. So this has to be the last part, and that's going to be the one that gives us our answer. So you want to always be frowning. But if you look here at the first one, that's smiling, so that can't be the answer. If you look here at the end, it's smiling, so this can't be the answer. Let's look at the very last one. The last one, we're frowning. That's half a frown. And then if you look here, still frowning, so E has to be our answer. The absolute maximum. So this is telling us we have an absolute maximum. This is a polynomial, which means it's continuous. And if it's closed, that means EVT occurs. You are 100% guaranteed that there's going to be an answer to this. So let's start off with f prime of x is equal to 3x squared minus 6x. We're going to set that equal to 0. F prime does not equal undefined, so we don't have to worry about that. I'm going to factor out my 3x, and I get x minus 2 equals 0. I get x equal to 0, and I get x equal to 2. I'm going to do my sign chart. Actually, let me move that over. I'm going to put my endpoint on my function, negative 2 to 4. Those were my endpoints. These are where my derivative was 0, at 0 and 2. If I look at the parabola, it was facing up, so those of you that saw me this afternoon are probably better with this, but I can do my sign chart really quickly by knowing that that's a parabola with zeros at 0 and 2. That would give me these signs. If you're not good at that, then you're going to have to pick a number between. I would put negative 1, substitute it into the factors. So I would get a negative times a negative, which makes the positive. I would pick a number in between here, which would be 1. Substitute back into here again. I would get a positive number times a negative number, which is why this is negative. And then the number here, I would pick 3. The number that I pick would give me a positive and a positive, which is why it's positive. So there's two different ways to do your sign chart. Now, given that we have that, I got to look at your possible max and mins. The graph is going increasing, flattening, decreasing, flattening, increasing. So I have two possible maximums. I have a maximum at 0, and I have a possible maximum at 4 at the endpoint. So the only way I could tell which one's going to be the actual maximum, I would have to make a table. At x equal to 0, I would substitute it into f of x. I get 0 cubed minus 3 times 0 squared plus 12, and so we get 12. F of 4, I would get x cubed, which is 64, minus 3x squared, which is 16, plus 12. So I get 64 minus 48 plus 12. So obviously, this value here is bigger, so this has to be the absolute max. This one is smaller, so this is a local max. Therefore, my answer is that the x happens at 4. If the graph of y equals, that function has a point of inflection at 1 comma negative 6. So let's start off with point of inflection. The only way a point of inflection would happen on a polynomial curve is if the double derivative at that point of inflection equals 0. So let's start on the left side. On the left side, I'm going to write in the derivative, the second derivative. Let's do that to the right. First derivative would be 3x squared plus 2ax plus b. Second derivative would be 6x plus 2a. This is a constant. This is a constant. Now, I'm going to substitute my second derivative into my equation on the left side. On the right side, we're leaving that equal to 0 because the point of inflection would cause that to be 0. The point of inflection is happening at x equal to 1, so I'm going to substitute in my x. So I get 2a is equal to negative 6, a is equal to negative 3. So I found a, which is not what they asked me for. I need b. Now, the only way I could find b is there must be another equation to use. If you remember the original point that they gave us the point 1 comma negative 6. If it's the point on the curve, then I should be able to substitute it into the y function. And when I substitute 1 in, the y value should be negative 6. So now I have another equation I can solve. 1 plus, now a was negative 3, times 1 squared is still 1, plus b minus 4 equals negative 6. So we get b minus 6 equals negative 6. Add 6 to both sides, and we get that b is equal to 0. The question was, what's the value of b? Therefore, b is equal to 0. Here we're going to be asked to find the number in C that satisfies the conclusion of the mean value theorem. So the mean value theorem that if I take the derivative, it'll be equal to the slope between the 2 points. So I'm going to come off to the right here. I'm going to find f of b, which is 3 pi over 2. That would be the sine of 3 pi divided by 2 divided by 2, again, would be multiplying by a half. So this, some of you are really confused about this. That's the same as saying x times a half. In red is my x, 3 pi over 2, and then multiplied by a half. So we actually get the sine of 3 pi over 4. 3 pi over 4 is in the second quadrant, sine's positive there, therefore the answer is root 2 over 2. We're going to find the f value at pi over 2, and so that would be the sine of pi over 2 times a half gives me pi over 4. That's in the first quadrant, sine's positive in the first quadrant, so we get root 2 over 2. So the derivative on the left side would be derivative of my outside, leave the inside the same, multiply by the derivative of the inside. My slope would be root 2 over 2 minus root 2 over 2 divided by 3 pi over 2 minus pi over 2. It's nice and easy when the slope value you get is 0. The problem a little bit nicer. Alright, so really I'm solving that the cosine of x over 2 is equal to 0. When is cosine equal to 0? That's the x value, so that would be at pi over 2. So this angle is what I'm looking for. The cosine of the red equals 0 happens when the red is pi over 2. Therefore, to solve for x, I will multiply and get pi. Therefore, there's my answer. It is within the interval. At what value does the function have a point of inflection? So y is equal to x to the negative 2 minus x to the negative 3. Y prime is equal to negative 2x to the negative 3 plus 3x to the negative 4. y double prime, which is what we need for a point of inflection, would be positive 6x to the negative 4th minus 12x to the negative 5th. Let's rewrite this guy. So I get 6 over x to the 4th minus 12 over x to the 5th. I'm going to multiply the first term by an extra x, and so we get 6x minus 12 all over x to the 5th. I'm going to set that equal to 0. I'm going to set this also equal to undefined. And when I set this equal to undefined, I would get that x to the 5th is equal to 0, x equals 0, but if you look at the original function, the domain of this function was x can't equal 0. When I set the derivative equal to 0, I actually get that 6x minus 12 equals 0. I get x is equal to 2. So when I do my sign chart, I would get 0, I would get 2. Undefined, cross it out because it's not part of the domain. I get a 0 here. Let's double check if there's a point of inflection. You actually have to check for the sign change. If there's no sign change, the answer is letter E. If there is a sign change, the answer is letter C. So we do have to check that the sign changes at x equal to 2 on the second derivative sign chart. So all I care about is right in between 0 and 2, which would be 1. Substitute 1 into my most simplified derivative, which is right here. When I substitute in 1, I get negative divided by a positive, therefore this sign is negative. Substitute in 1,000, I would get a positive divided by a positive, which gives a positive. So the point of inflection is at x equal to 2 because the sign does change. You have to check for the sign change. So if you're watching this, it means that you're taking a little extra time to study. So I really do want to stress the second derivative test because some of you do get confused. If I asked you to use the second derivative test, let's say on this function, an easy function, minus the 2x squared. Something like that, plus 5. If I asked you to use the second derivative test, you should understand, number one, that the second derivative test is checking if you have a max or a min. That's all it does for you. Something you already know how to do. I'm going to purposely use the second derivative test now. So I'm going to find the first derivative, which bring the 3 down, it cancels the divided by 3, and I get x squared minus 4x. I'm going to set that equal to 0, and I get that x times x minus 4 is equal to 0. Y prime does not equal undefined, so I don't have to worry about that. And we get x equals 0 and x equal to 4. So the second derivative test says you don't have to make a sign chart. Instead, what you do is you find the second derivative. The second derivative, I'll put it over to the right, is equal to 2x minus 4. And all you do is find the second derivative at the 2 points where the derivative is 0. So y double prime of 0 would be negative. Y double prime of 4 would be positive. So what do we figure out? We figure out by looking at these graphs. If the second derivative is negative, you're concave down. What I just figured out is that this is a maximum. If you're concave up because you're positive, now you've just figured out that this here is a minimum, and that's what the second derivative test does for you.